Hello everyone. In this short video, I want to talk about batch versus incremental training. If you remember my previous video on function approximation using add-a-line networks, I showed you that we update the weights and the biases of different layers using this formula where alpha was the learning rate, this S where these vectors were called the sensitivity terms, and the A's were the outputs of each layer, okay? And the way that we updated these weights, we did it per input, right? Per epoch. So if you go and look at the code that I provided last time, you see that as I go through each epoch and as I go through each input, so here ND is the number of the data points or the number of inputs. Remember, for this function, I broke down the input range from -2 to 2 to 200 data points, and I fed each one of those data points to the network, and I calculated the sensitivity terms and the A's, and then you see per each one I updated my my weights and biases. Okay, then I went to the next input, I did that. So actually per epoch, each one of these weights and biases, whether they are a scalar or vector, they have been updated 200 times before we go to another epoch. This is called incremental training. This is what we did in the previous video. Another way that you might hear they do it is called the batch training. And I want to clarify, when we say batch training, what do we do? So here, instead of doing the update per input, what do? We calculate this term, SM, A of previous layer transpose, but we don't immediately apply it to the weight. We added over all of the inputs that we want to apply to the network. So here this Q is, for us in the code, is N sub D, okay? The number of data points, the number of inputs. We added per all number of inputs, we added per all of those, right? Then we take an average by dividing by the number of data points, then we apply that average of all of those update terms multiplied by the learning rate, and then we update the weights and biases. Okay, you see that? So instead of all individual update terms from each one of the inputs, we use an average of all of those update terms, and then we apply the average to our weights and biases. So we only update weights and biases one time per epoch, but using the average data. Okay, so if you want to do that in the code, what should we do? So now this is what I have. If you look here, that's the same code, except I start the summation terms in the start of each epoch. I start them at 0, as you can see. And then as I go through each and every one of the inputs, I add to these summation terms, this S1P, S1, S2, A1, and S2. This P is the same as A0. Okay, so you see, I add all these summations, and I calculate the summations that I started from 0, and in each epoch they start at 0, and add them all here for each data point, and then at the end, you see, I divide those summation by the number of data points to get an average, and then I add the average multiplied by negative alpha to the weights and biases. Okay, now one thing I have to mention, that in my previous code, there was some part that I did not code correctly, and so for that reason I need to emphasize that, and I'm gonna upload the new version of my code for the previous video. I also added under the video description, and that was the part that I calculated the cost function. If you look at my previous video, the way I calculated this cost function was like this. It was JK. The cost function for the kth epoch was basically T2 minus AII and just squared. It was something like this. There was no summation, and it was something like this, which is wrong. Okay, so because it is for all of the inputs, not just one of them. Okay, it was TII, sorry, minus A2, something like that. Okay, this is wrong. This is only for one data point, not for all of them. What you need to do after all the weights are updated, you need to calculate, after all the weights are updated, you need to calculate the output of the network, A2. So I use this for loop that I also use for my plotting. I use that, and then what? Once you have that A2, the output of the network, then you subtract the entire A2 from the entire target, square the vector, and sum it up. That is the cost function. So this thing that we did last time, this was clearly what? This was wrong. The way we did it, we just did it for one input instead of the entire input set. Okay, so you need that, and if you do that, then at the end, again, you can get rid of this if you want, or you can keep it because these aids are always updated. Okay, but here I did the same thing. If you look here, you see I calculated, after I did this batch update for that epoch, I calculated the output of the network A2, subtracted vector A2 from vector T, squared it and summed it up to get the cost function for that epoch. And then I'm going to what? I'm going to plot it. So you see here, the batch update of the weights is done outside the loop for the data points using the average values. And you might say, well, that is going to smoothen out all of the small updates through each one of the inputs, and so that should give you a lot better performance. Well, not necessarily. Here, look, I use the same data that I used in this previous one. I used 20 neurons. I use the same learning rate, and I use 200 epochs. Okay, the same as previous time, right? And you expect to get a good result, but look what happens. You see, if you look at your cost function, you see it has not even got close to zero. It's still a huge number. Okay, and so what you need to do is you absolutely need to go for a lot more epochs, right? Or you might say, what if I bump up the learning rate? Remember, if you bump up the learning rate, you have the chance of not converging. Okay, so you have to be careful about this learning rate and not just arbitrarily go very large, right? So I would rather bump up my number of epochs, and here you might say, well, just make it 10 times more. Yes, and you might say, well, it should work, huh? Well, let's try out. So you see here, the function approximation is not that good. You might say, well, look here, your cost function is approaching almost zero. So why is it the problem? Well, look at my cost function. It looks like zero, but it's not. It's actually 53, as you can see in the y value. It's still not zero. Okay, because you are comparing it to 8,000, the initial value. So yes, 53 looks like a zero, but it's not. So you have to go, that number, it has to go very, very close to zero. Otherwise, you're not going to get anything nice in here. So you might say, well, make it 10,000. Fine. Let's do 10,000, see if it does the job, right? Let's keep it going because it seems like it was still going downward. So let's wait a little bit more. You see, now you get a little bit better approximation, but look at here. Again, if you look at the final value, still 11. So should I wait more? Maybe, but maybe you don't have enough neurons in your system, right? Maybe you need to add more neurons, more learning units to help here. So if that's the case, Instead of just adding more and more epochs, I add a little bit more to my neurons, make it like 3 times more neurons. Let's see what happens now. Okay? So they give more flexibility to the system. Of course, you should not just bump up them big time because you only have 200 points. Okay, and you should not do overfitting, but here you see you got a little bit better data. And if you look at the final value here, it's 4. Okay, so now you're getting there. You're getting there. Maybe add a little bit more to the epochs, and hopefully it goes close to like 1 or less than 1 or something. And you give it enough neurons and enough time for the system at this small learning rate. Okay, so now I stop the video so it converges here, and you see now I could get it to approximate my function relatively well. And if you look at my final number, you see now it's around 1. Okay, so that's a small. If you can go below 1, that is going to be even better. But now I get it to relatively do a good approximation, although you see here it does not do an amazing job in the curvature of the function. And although the error is good, but I guess there are too many points now, so the curvature is not showing itself very well. So maybe I need to go down on this and allow this to do its job. Yeah, there we go. You see now it is going below 1, and I'm approaching the function quite well. And here actually a gain scheduling, a learning rate scheduling would be really helpful, which we'll do it in one of our future videos. You see, when you're getting very close to the end, the learning is very, very slow. So that's a time to bump up your learning rate. Okay, if it's kind of plateaued, maybe you need to change your learning rate from that small number, especially because you're averaging now. So a very small learning rate along with the averaging is gonna take a lot of times and a lot of epochs. Okay, so but you see, you can get it to approximate the function relatively well. So for 200 data points, an average of 0.87 is not really a big error, although here at the beginning you're not doing a super amazing job, but for the rest of the curve is not so bad. So just wanted to clarify this for you, this batch update versus the incremental update, and just tell you that if these are the contours of the cost function, and this is a WB space, right? So this guy is like the W and this is like B. Of course, this is assuming that you only have one of each. And this is your start point here in this circle, and then that X here at the center is the global minimum. So with incremental updates, your system goes through all of those oscillations. With this batch, you're kind of smoothing it out and taking the average. Now, of course, here you see that you need to be a little bit more patient, have more epochs, or you need to change your learning rate along the way to allow it to go toward this minimum a little bit faster. And that's what we did. We increased the number of epochs, although as I said in one of our future videos, I'll talk about how to change this gain alpha along the way. So hopefully this video was useful to you. As I said, I will update the code of the previous video, this part of it that we added instead of this wrong line. And in the new code that I have, this is already taken care of, so it should be good to go. Thank you for your attention. I'll see you in the next video.